The Indian Space Agency, ISRO, may not be the most well-known space agency across the world. However, even with a small budget and a late start compared to other countries, its achievements have been remarkable. From sending 104 satellites in a single rocket, to inserting a probe in a Martian orbit on their first attempt, India is quickly becoming a global player in the space scene. And whereas space agencies like NASA or ESA have a budget of billions of dollars, ISRO has successfully completed interplanetary missions at a fraction of the price. Next up for ISRO is the ambitious Gaganyaan mission, which will be India's first manned space venture. So, what exactly does ISRO hope to achieve with the Gaganyaan mission? Will this be the forerunner of bigger and better things? I'm Alex McColgan and you're watching Astrum, and together we will investigate the details of the Gaganyaan mission and what the Indian Space Agency hopes to achieve in the future. Raquel Sharma is the first and only Indian citizen to travel in space up until this point. He was part of the Soyuz T-11 mission, which was a collaboration between ISRO and the Soviet space program all the way back in 1984. During this mission, he stayed aboard the Salyut 7 space station, a tiny space station that existed back in the 1980s. Since then, there have been plans for further manned missions from India itself. One such mission began in 2006, but the project never took off due to low funding, meaning it never passed the initial planning stages. Fortunately, however, ISRO's success in space science over the past decade has led to renewed interest in a manned mission. All going well, this will be the next breakthrough for the space agency. In fact, this goal was confirmed by India's Prime Minister, as one of his commitments since being in power has been to send Indians to space again by 2022, and this time independently from any other space agency. So, how will they go about doing this? Well, the initial plan is that ISRO's pride and joy, the GSLV Mark III launch vehicle, will take the Gaganyaan spacecraft into a low Earth orbit at 400 kilometers altitude for 7 days. The spacecraft consists of a crew module, where the astronauts stay, and a service module that contains a variety of support systems. The spacecraft itself will be propelled by 2 liquid propellant engines. These 2 modules combined make up the orbital module, which can provide life support to the crew for 7 days before they splash down in the ocean. This will be an impressive feat. 7 days in space is quite a long time for a simple capsule. Generally speaking, capsules transporting astronauts have only ever needed to take short trips. For instance, the Russians have docked with the ISS in only 6 hours after takeoff, and even for longer trips, it takes at most about 2 to 3 days. To meet the 2022 deadline, ISRO has 2 unmanned test launches planned for December 2020 and July 2021 respectively. The 2 unmanned flights will help ensure that everything functions correctly, including the environment control in the modules, and to test whether the capsule will remain safe for humans during the duration of the journey. Human spaceflight simply has to be a serious step up in complexity and thoroughness compared to robotic missions, as there's a lot more at stake should a manned mission fail. Additionally, ISRO has developed a female humanoid robot named Vyommitra. This humanoid robot will be part of both the manned and unmanned missions of Gaganyaan. During the uncrewed missions, Vyommitra can mimic human functions and will record parameters such as blood pressure and heart rate. Vyommitra will also be able to recognize and understand astronauts, and ISRO hopes to see if she can be of some help to them during the manned mission. Other space companies see the value in a robotic colleague too. Recently, SpaceX sent an anthropomorphic test dummy named Ripley to mimic human functions in a similar fashion to Vyommitra. In January 2020, ISRO shortlisted 4 men who are going to be part of the Gaganyaan mission. The 4 candidates have already begun their 12-month training at Gagarin Research and Test Cosmonaut Training Center in Russia. Now, of course, humanity already has a lot of experience in low Earth orbit, so this mission is less of a scientific mission, rather more of a technology demonstration mission. However, it is an important first step for ISRO and its future independent missions, which will include Chandrayaan-3, ISRO's third mission to the Moon, and Shukrayaan-1, its first attempt at a mission to Venus. ISRO even hopes to one day build its own space station. So there we have it, a look at some of the exciting missions that will be coming from India. Personally, I think this is a good thing for the space sector. Competition breeds innovation, and if India can make space travel safe and cheap, it can benefit the whole world going forward. India's Chandrayaan-3 moon mission has already proven historic. It put India in the history books for being the fourth nation to ever successfully land a spacecraft on the moon, and the very first to ever land at its south pole. The lander Vikram and the rover Pragyan already made discoveries that could profoundly impact our understanding of the moon's chemical composition and geological history, and has given the world vital data that will aid future return missions to our lunar neighbour. And yet, for all the praise, which is well deserved, it's what Chandrayaan-3 did not discover, but should have, that I find the most intriguing. Have you noticed it too? India's NASA equivalent, ISRO, the Indian Space Research Organisation, made press releases before the launch, and there was always one thing they claimed they were primarily there to find. One reason the South Pole was picked out over all other locations. One mystery about the moon that is deepening the more we investigate, and yet needs to be solved before we can expect to start setting up permanent bases up there. Simply put, where is all the water? I'm Alex McColgan, and you're watching Astrum. And today we'll take a look at Chandrayaan-3, explore its successes, and attempt to use its discoveries to answer that one important question. It was India's Chandrayaan-1 mission that helped provide some of the clearest proof that the moon's polar craters might hold water ice. Water on the moon had been hypothesized since the 1960s, and in 1971, Apollo 14 found some traces of water vapor at the lunar surface. But water ice itself proved difficult to pin down. Scientists thought that if water ice was anywhere, it would be in the craters at the north and the south lunar poles. These craters were aligned such that they never received direct sunlight, and thus were very cold, some of the coldest places in our entire solar system. The perfect forming ground for ice. Sadly, images of these crater cold traps were too low resolution, or simply too dark for us to know for sure, and while there were numerous detections of hydrogen on the moon's surface, it was unclear whether this took the form of actual water ice or not. However, in 2009, signs of hydration began to emerge. Chandrayaan-1, carrying a NASA Moon Mineralogy Mapper, found the first definitive spectrographic signatures of water ice in dozens of craters congregated around the moon's poles. This water map was later confirmed by Chandrayaan-2, leaving scientists increasingly confident that there was potentially 600 million metric tons of water ice to be found in the moon's darkened craters. Water on the moon is a big deal. More and more nations have goals of setting up bases on the moon, and being able to source your water from the moon's surface saves you from having to spend huge amounts of resources getting it up there. Water is vital for human life, but also could be broken down for hydrogen and oxygen, useful ingredients for rocket fuel, or a breathable atmosphere in your moon base. So it should come as no surprise that when Chandrayaan-3 began to make its way towards the moon, one of the things the media reported it was hoping to find was water ice. Chandrayaan-3 was launched on the 14th of July 2023. It was made up of a lander module called Vikram, a small rover called Pragyan, and an orbiter module that carried the other two components across the Gulf of Space. On the 23rd of August, Vikram, with the little Pragyan tucked inside, touched down on the moon's surface at the beginning of a lunar day. But time was not on their side. Chandrayaan-3 was a surprisingly cost-effective mission. While NASA's Artemis mission launches will each cost on average $4.1 billion, the entire Chandrayaan-3 mission only came to 6.15 billion rupees, or about $75 million, ironically less than what many modern blockbuster space films take to produce. Perhaps Hollywood should consider filming their next moon film on site. However, with this lower budget came technological limitations. When the lunar night fell, Vikram and Pragyan would be subjected to temperatures of minus 120 degrees Celsius, temperatures they were not designed to survive. A lunar day lasts 14 Earth days. The Chandrayaan-3 mission would need to complete its major objectives in that time, as their odds of surviving to the day after that were slim. And so Vikram lowered its ramp, and Pragyan, the rover, powered up and headed out down onto the moon's surface. Pragyan is a 27 kilogram, 6-wheeled rover that came equipped with an alpha particle X-ray spectrometer for analyzing the chemical composition of the moon by firing radiation at it and seeing what wavelengths bounce back, and a laser-induced breakdown spectroscopy instrument that does a similar thing, but this time by firing a laser at the target of interest and analyzing the light wavelengths that are released by the resulting plasma. These two tools together would be enough for Pragyan to attempt to find water or any other interesting substances, confirming their composition for scientists once and for all. And so it set to work, deploying both instruments on the ground next to it. Within days, the results started to come in. Aluminium, calcium, iron, chromium, and titanium were all found on the moon's surface, along with other interesting elements like oxygen. Indian scientists were most excited at the first ever in situ measurement of sulfur at the moon's pole. Sulfur is an exciting element to find, as it helps us understand the evolution of the moon over time, and indicates there used to be volcanic activity in the region. But in spite of all these discoveries, there was one element that was not showing up in the analysis. The all-important hydrogen was notably absent. Pragyan set off to explore further afield. Guiding the rover was all done manually by scientists back on Earth, looking through Pragyan's onboard navigation camera. This had to be carefully done, as the signal delay between Earth and the moon meant that orders for the rover to halt lagged by a little under 3 seconds, time that might make all the difference if the little 6-wheeled rover was to avoid overturning. And indeed, this nearly happened. Early on in Pragyan's journey, the rover had to speedily stop to avoid falling into a large 4-meter crater scientists hadn't initially realized was there. I say speedily. Pragyan's move speed was 1 centimeter per second, hardly the fastest of sprinters. Over the course of its 2-week life, Pragyan traveled no more than 100 meters from Vikram. Fortunately, the crater was detected in time, and scientists were able to turn around and choose another route. However, when you look at Pragyan's route, you notice that there was a second moment where Pragyan did not travel down into a crater it came across, instead electing to go around. No photos of this second crater are currently available, so we are left to conclude that no ice was spotted there. Vikram itself did not remain idle during this time. It performed temperature readings of the moon's surface, digging 10 centimeters deep to measure the moon's warmth at different depths. It measured the plasma content of the atmosphere. Good news, there's not much up there, so radio communication to the moon likely won't get much interference. It detected a possible moonquake, which, given the small 2-week window, was some excellent timing. At the very end of its journey, in a moment of final enthusiasm, the Vikram lander even successfully performed a 40 centimeter high hop, firing its boosters to lift itself off the ground, moving 30 to 40 centimeters along from its previous destination. Indian scientists had wanted to test how easy it would be for future landers to one day propel themselves back into orbit from the moon, and this was a useful practice run. But none of this helped the Chandrayaan-3 mission to find water ice. By the 4th of September, time was up. Vikram and Pragyan were ordered to power down. ISRO scientists had hoped to wake them up again once the night ended, but this hope proved to be fruitless. The two lunar explorers had communicated with Earth for the last time. ISRO and the scientific community at large lauded their efforts and called the mission a success. And indeed it was, as India had gained first-hand data from the moon that would be extremely helpful in building a picture of conditions at its poles, along with furthering our understanding of the moon's history. However, it definitely raises a mystery. When I first heard that water ice had been detected on the moon, I envisioned in my mind frozen ice lakes, or possibly tall penitentes. Perhaps a light frost, as vapor from the moon's atmosphere ended up trapped in these darkened craters, freezing over the surface and building up over time. We know from orbiters like Chandrayaan-1 that water ice is indeed in these craters, and yet Chandrayaan-3 has joined other missions in failing to actually see this ice for themselves. I remember feeling similarly disappointed when I first saw the images captured by ShadowCam, a NASA camera carried on the South Korean Danuri moon orbiter. ShadowCam was so good at detecting light, it could see into the polar craters that hadn't seen direct sunlight in millions of years without issue. And yet, once again, there was nothing there. Nothing but arid dust. Given that Pragyan's analysis of the lunar regolith revealed no signs of water molecules, where is the water ice that Chandrayaan-1 detected? While this mystery is confusing, Chandrayaan-3 offers us a possible answer. Not through Pragyan's explorations, it's actually Vikram that possibly hinted at the solution. When Vikram used its chased temperature sensor, it was able to take 10 different readings of the moon's temperature, starting at the surface and working its way down in 1 centimeter increments. What it found in the space above the moon's surface was a temperature a little under 60 degrees Celsius. Definitely too hot for you to walk around in if you happen to be on the moon and somehow didn't care about the lack of air. But curiously, as Chase measured deeper and deeper beneath the surface, this sweltering temperature dropped off fast. By 8 centimeters deep, the new temperature Vikram was detecting was minus 10 degrees Celsius. That's a big drop. From this we can see that lunar regolith is a really poor heat conductor. But that also indicates quite clearly that the best place we're likely to see ice is not resting on the moon's surface, but we actually need to look beneath it. There's much we don't understand about the moon and its water cycles. There's growing evidence that the moon contains quite a lot of water, and yet extracting it will take understanding where that water can be found, and how it moves throughout the long lunar days and nights. Is it affected by solar radiation? Is it trapped in hidden deposits? Although Chandrayaan-3 only lasted 2 weeks, which I'm sure is less time than ISRO scientists would have liked, it has offered us vital insights into the conditions on the moon. As far as water is concerned, at the very least, it has given future astronauts this one piece of advice. If you want to find a drink of water on the moon, you might want to start by bringing a shovel. Some of you may have heard of the amazing feat produced by ISRO, or India's space agency, where they successfully inserted a probe into Mars's orbit on the first time of trying, for a relatively minuscule $66 million back in 2014. This made it the first space agency in the world to have a successful Mars mission on the first time of trying, plus it is the first Asian agency to get to Mars. This by itself is pretty impressive, but it's been in orbit for over 5 years now. So what has it done and seen around Mars? And has it contributed anything beyond what the NASA and ESA missions have already achieved? I'm McColgan and you're watching Astrum, and together we will investigate the findings and imagery of the Mangalyaan mission to Mars. Mangalyaan launched from India in 2013 on board an ISRO rocket designed to insert satellites into orbit around Earth. As the rocket didn't have the thrust needed to get Mangalyaan to Mars, the probe had to use some of its own fuel to leave Earth orbit, which it achieved gradually over several orbits. Upon arriving at Mars, it was inserted into a highly elliptical orbit. At its furthest point, Mangalyaan is almost 80,000 kilometers from Mars, and its closest approach takes it only 420 kilometers above its surface. This orbit is much different from NASA's Mars Reconnaissance Orbiter, which remains close to the Martian surface in order to image the surface at a much higher resolution. This is due to the different science goals of the missions. Mangalyaan does seem like more of a technology demonstration mission, although scientific instruments on board had a particular focus to study Mars's upper atmosphere. However, what I really like about this mission is that they put a pretty normal camera on board to image the Martian surface. This means the raw images are true color images, seeing Mars as you would see it if you were in orbit. Having a highly elliptical orbit also means we can view the whole of Mars in one go, reminiscent of the old NASA Viking missions. I must say that at this distance, Mars is a beautiful planet. The carbon dioxide and water ice caps are visible at the planet's poles. Various shades of rock sediment and dust patches across the surface provide an interesting contrast. Craters of various sizes span the planet. And of course, some of Mars's most interesting features are visible, like its long dormant shield volcanoes and huge valley structures. What's also visible, even from this distance, are some of Mars's famous giant dust storms. In this image, the dust storm spans thousands of kilometers across the northern hemisphere. These storms can last weeks to months, almost completely blocking sunlight from reaching the surface under the densest parts. Storms like these caused big issues for the solar-powered rovers Opportunity and Spirit. Some smaller storms can also be seen in some of the other global views of Mars. Orographic clouds are often seen over the volcanoes of Mars, and yes, these are water ice clouds. Although the atmosphere of Mars is a lot thinner than on Earth, and most of its water has been lost, there is still a small amount of water vapor in the atmosphere. And in this image, we see 3 smaller volcanoes, with orographic clouds forming over Elysium Mons, the center volcano. Orographic clouds form when air is forced higher as it moves over high terrain. During a closer approach over Elysium Mons, clouds are still visible, but more apparent are the trenches around the volcano. These are called fossa, trenches formed by the stretching of the plate they reside on, often caused on Mars by the sheer weight of the nearby volcanoes. The fossa widen as more material falls in. Think of it like a series of connected sinkholes on Earth, but instead of material being eroded under the surface causing the pit to open up like on Earth, on Mars the cause is due to a fault under the surface, sometimes up to 5 kilometers deep. A close-up examination of one of the fossa reveals something interesting. Right in the middle of this image, you can see what appears to be a tall, wavy structure. Mangalyaan inadvertently captured a giant dust devil, the shadow of which stretches out for several kilometers. Once you notice that one, you'll realize there's actually a few in the image, each with a long, windy shadow. Orographic clouds have also been seen over Olympus Mons, the tallest volcano in the solar system. From the base to the peak, Olympus Mons is 3 times taller than Everest and is 600 kilometers wide. As a result, it is easily visible and recognizable even from this altitude. From this view, you can also easily see where lava from ancient eruptions has flowed down onto the plains surrounding the volcano. Looking a bit further across, you see 3 more big shield volcanoes, with a few smaller ones to the north. You'll also start to notice this weird patch, which looks almost like a labyrinth, aptly called Noctis labyrinthus. In a similar vein to the Elysium fossa, Noctis labyrinthus is thought to have formed because of the huge volcanoes to the northwest, but this time perhaps due to collapsed magma chambers deep under the surface. Research is ongoing. Connected to Noctis Labyrinthus is the famous scar of Mars, Valles Marineris. What I really love about these images is that, just like the Viking missions, water ice fog can be seen filling the chasm. This valley is 4,000 kilometers across, and channels seem to flow out of it to the east into chaos regions, similar but smaller than Noctis Labyrinthus. This hemisphere of Mars is lower than the rest, which indicates these outflow channels, which do look a lot like river channels on Earth, flowed into a once ocean. Ground-based rovers have since uncovered further evidence for this ocean, finding hydrated minerals in these regions. Another really interesting visual landmark on Mars is Kasai Valles, north of Valles Marineris. Again, this shows a very interesting outflow channel, starting in the east and flowing to the west, depositing into the same region but further north as Valles Marineris in the south. Most scientists propose these channels are carved out by mega flooding events in the distant past, when liquid water was abundant on the Martian surface. There's also some argument that glaciers carved out these channels. In fact, there are a lot of outflow regions heading into this once ocean. Here's Ares Vallis, again probably carved out by mega flooding events. All these channels are too wide to have supported a constant river system, at least at this size. A very large yet odd crater-like structure can be seen from the Mangalyaan images. This is Orcus Patera, 380 kilometers long at its longest point. Scientists are a bit baffled about how this could have formed. Craters are always circular, plus Orcus Patera isn't very deep at only 500 meters. Volcanic activity could be a cause, but there's no cauldron. And so there have been no theories that scientists can settle on so far. What do you think it could be? Some of the images focusing on the limb of the planet have also been able to see Mars's atmosphere, which I think is quite beautiful. Some very oblique shots can even see a cloud layer high in the Martian atmosphere. And due to Mangalyaan's ecliptic orbit, sometimes Mars's moon Phobos comes between the planet and the probe, imaged here against the backdrop of the planet. The last thing I want to showcase in this video is the prevailing wind direction on some parts of the planet. Even though we are quite zoomed out by here, in this image, showing a few thousand kilometers across, we can easily see where craters have blocked the darker dust from moving across the surface with the wind. The wind direction in these parts must have been like this for a while, for it to be so noticeable from space. A closer look at the surface shows how this effect can happen with smaller craters too. We are nearly 1,000 members on Patreon, and it's so exciting to see our community grow. If you want ad-free videos, wallpapers, and to join a community of hundreds that love space, sign up below so we can finally reach 1,000. It's more than a number, it's a milestone for everyone who's been part of Astrum's journey. Each new astronaut makes this constellation bigger, the conversation deeper, and the experience richer for everyone. So if you've been watching from the sidelines, now's the perfect time to join the community.